Good morning, all. In previous lecture, we have seen some examples based on the formulae of a periodic function. So let us see the next function, that is Heaviside unit step function or just unit step function, and how to find the Laplace transform of this unit step function. So the definition of unit step function or Heaviside unit step function is the unit step function, that is that first letter u is used for the notation, that is u of t minus a. This is your unit step function, or you can say this as Heaviside unit step function. So what is the definition? First see the definition of this unit step function. So u of the function u of t minus a equal to, this function is equal to 0 when t is less than a and equal to 1 when t is greater than or equal to a. So this is the definition of unit step function. And how can you check that this is the unit step function? That is the function which contains the bracket. You can remember by this hint, that is the function which contains the bracket t minus a bracket, or the equation which contains t minus a term. A is your constant, you can say it as constant, that is number. So the function contains t minus a term or t minus a bracket. That function, you can say it as unit step function. So as we have seen in previous lecture, that to find the Laplace transform of periodic function, the formula for periodic function is different. That is to solve the examples by using periodic function formula, we are not use the previous properties of Laplace transform or standard formula of Laplace transform for finding the Laplace transform of periodic function. There is only one formula for Laplace transform of periodic function, and we are use this formula to solve the examples in previous lecture. So again, this is the next function, that is unit step function. So the Laplace transform formulae for this unit step function are again different. So these are some formulae of Laplace transform for this unit step function. So first formula is this is the function, and what is the Laplace transform of u of, that is unit step function of t minus a equal to 1 upon s e raised to minus as, and this a we have to take from this function, the given function in example. So this is the first formula for Laplace transform of u of t minus a. Then Laplace transform of product of two functions. First function is of f of t minus a, second function is unit step function u of t minus a. And if there is a product, then what is the Laplace transform? Is equal to e raised to minus as Laplace of ft. That is, to apply this formula, first compare the given example with this function f of into u of, then find the value of a, that is the bracketed term, and t minus a. If there is a bracket in example as t minus 2, then a value is 2. So by comparison, find the value of a, put here in this formula, then find ft and then take its Laplace transform. That is, ft is, we have to take this ft from this f of t minus a. So if f of t minus a is, or you can say f of t minus 2 is t minus 2, then ft is only t. So how to find this ft from f of t minus a? You can see in further examples. So we can see in these examples. Again, this is your second formula of Laplace transform of f of t minus a into u of t minus a, that is product of two functions. One function is unit step function, another function is a regular function in the form of f of t minus a. Then from this you can remember this formula. This is again, you can remember as a formula, but you need not to remember this formula, because this formula comes from this second formula. That is, just write, instead of t minus a, just write ft ut equal to, so here from f of t minus a you just take ft, that is a value is here 0. We have taken here a value 0, so we get ft and ut. So again this value a equal to 0 put here, so e raised to minus 0 into s, that is e raised to minus 0. E raised to minus 0 value is 1, so 1 into Laplace of ft, so remaining term is Laplace of ft. So this formula comes from this. Again there are some examples of this formula. Then third formula is for product of two functions. One function is regular function and the another function is your unit step function. So ft into ut minus a. Second function, the difference in second formula and third formula is ut minus a are similar, but in second formula t minus a bracket there, and in third formula only t variable there. So f of t minus a into ut minus a, this formula, and for third formula ft into ut minus a is equal to e raised to minus a's Laplace of f of t plus a. So again to apply this formula, again compare this left side with the given example, find the value of a. This value comes from this u function, that is unit step function, and f of t plus a comes from this ft. So first find f of t plus a from this given function ft, put here value, then take its Laplace transform and multiply it by e raised to minus a. That is your answer of given example. So this is the theory. First example is your theory, that is Laplace transform of this unit step function. Unit step function is ut minus a. So to find this Laplace transform of heavy side unit step function, we are using here definition of Laplace transform. So Laplace transform of ut minus a, because you can consider as this is your example. Function is given with condition. Function is given and condition is given. These two things if given, then you have to use the Laplace transform definition. In previous lecture we have seen that if two terms or two things are given, that is function and condition, then we have to use Laplace transform definition. And if three things are given, that is function, condition and the value of period, then we have to use, to find the Laplace transform of that given example, we have to use periodic function Laplace transform formula. So here function and condition are given, so two things are given, so we have to use Laplace transform definition. The definition is 0 to infinity e raised to minus st ft dt. So Laplace transform of this unit step function ut minus a equal to, so here function ft is given in the form of ut minus a. So here function is your unit step function and its value is, here ft is given as ut minus a, and ut minus a is given in two values, that is it has two values. When t less than a, the value of unit step function is 0, and when t greater than or equal to a, the value of unit step function is 1. So this value is 0, so we need not think about this condition. Just think about this second condition, that is when t greater than or equal to a, the unit step function value is 1. So 0 to infinity, this limit changes to a to infinity, because from a onwards or greater than a, the value of this unit step function is 1. So put this ft as ut minus a, then ut minus a value is 1. So put ft, that is ut minus a equal to 1, and for one value the condition is different, that is a2 onwards the value is 1. So a2 onwards means lower limit is a and upper limit is fixed from this Laplace transform definition, that is infinity. So a to infinity function value is 1. So solve this, that is e raised to minus st integration by using e raised to bracket formula. E raised to bracket integration is this formula we used many times in previous examples. So in detail you can check these videos for the formula of bracket formula. E raised to bracket integration is e raised to bracket upon derivative of bracket. So e raised to minus st, that is minus st is your b value. So e raised to b, e raised to minus b st, that is e raised to b upon derivative of b, that is b value is minus st. Minus st derivative is minus s by using kx derivative. kx derivative is s, that is constant into variable, derivative is constant. So minus st, here t is variable, so constant into t is derivative is minus s from a to infinity. So for upper limit e raised, these limits are for t because this integration is with respect to t. So put t equal to infinity, and for lower limit t equal to a. So for upper limit t equal to infinity, e raised to minus s into infinity, that is e raised to minus infinity. E raised to minus infinity is 1 upon e raised to infinity, and anything raised to infinity is infinity, so 1 by infinity is 0. So for upper limit we get 0. Then for lower limit, this minus sign and lower limit minus sign will change to plus sign. So plus 1 upon s as it is, e raised to minus s into t value is a. So e raised to minus as. So this is your answer of this Laplace transform of unit step function. So further are the particular examples based on this unit step function. So this is the theory. This example you can take as assignment. Then again there is a extra term you can suggest here, that is Laplace transform of unit step function is equal to 1 by s e raised to minus s, and this is your formula. You have to remember this formula, and this formula we have proved here. Then Laplace of ut, that is from this ut minus a we have to take ut only, that is put a equal to 0 here. So Laplace of ut equal to e raised to a equal to 0, that is e raised to minus 0, e raised to minus 0 is 1, so we get 1 by s only. So this is again your formula. So further examples are based on unit step function, these formulae. So the examples which are depends on this formulae, that is unit step function Laplace transform formulae. For that, here there is a one concept, that is we have to first express the given function in the form of Heaviside unit step function. That is, we have to convert the given example in the form of unit step function and then use the its Laplace transform formulae. So there are 1, 2, 3, 4, 5. So this formula and this formula you can this comes from first formula we get Laplace of ft equal to, that is put a equal to 0, we get 1 by s. So this formula comes from first. So there are mainly only 3 formulae, 1, 2 and 3 for unit step function. So how to convert the given example or given function into Heaviside unit step function, these examples first we have to see, and then we can see the examples of Laplace transform. So first example is express the function in the terms of Heaviside's unit step function. So this function is given ft equal to sin t, sin 2t, sin 3t, and the conditions are given, 3 conditions are there. T is in between 0 to pi, ft value is sin t. T is in between pi to 2 pi, ft value is sin 2t. T is greater than 2 pi, ft value is sin 3t. So this function doesn't match with this unit step function. That is, unit step function contains the bracket term, that is t minus a bracket should be there for Heaviside unit step function. So this function doesn't contain that bracket, t minus a bracket. So hence we have to convert this function into Heaviside unit step function. So how to convert this? So there is one standard formula to convert the given function into unit step function. So this is the formula. If to express the given function in the form of unit step function, so if given function has f1, f2, conditions is like this, 0 to a function is f1, t greater than a function is f2, then this is the formula for having unit step function. So function can be converted as f1 into ut minus a plus f2 into ut minus a. That is, if two functions are given, then this is your formula. That is f1 plus f2, and in the product we have the bracket here. So this bracket there is a hint you can remember as This formula you can remember as from this condition. So from this condition, this bracket comes, that is, if 0 is there, so ut minus 0 minus, if a is there, so ut minus a, and ut minus 0 is ut, so ut minus a. So this bracket comes from this condition, and here t greater than n means only as there is a two limits, lower limit and upper limit for the condition, then there are two terms. If there is a one term only, so take only one term, that is, if a is there, so take ut minus a. So this bracket comes from this second condition. So f1 into f1 from f1 condition, this bracket comes here, and plus f2 into from this condition, second bracket comes here. So this is your formula for converting into unit step function. And if there are many functions f1, f2, f3, f4, etc., so this is your formula, f1 plus f2 plus f3 plus f4, etc. If there are 5 functions, etc., then plus f5 you can write. So f1 into from first condition, this is your bracket. So from 0a take ut minus 0 minus ut minus a, then plus f2 into from second bracket take this bracket. So as there is a lower limit and upper limit as a and b, so take ut minus a minus ut minus b, plus f3 into from third condition b and c there, so ut minus b, ut minus c, take this bracket, plus f4 into, as there is only one term, that is lower term c, so take only one bracket, that is ut minus c. So the u brackets comes from these conditions. You can remember like this. So this is your example. There are 3 functions. So how to convert? So ft is equal to write these 3 functions in the addition form. First function is your f1 plus f2 plus f3, and then take the bracket into multiplicative form. So sin t plus sin 2t plus sin 3t, and then take the bracket to each that term. Sin t into bracket plus sin 2t into bracket plus sin 3t into bracket. So in first bracket we have to take first condition is 0 and pi. So we have to take in bracket u minus u, that is ut minus 0 minus ut minus pi, ut minus 0 minus ut minus pi, plus second function sin 2t into second bracket. In second bracket comes from second condition, pi and 2 pi there, so ut minus pi minus ut minus 2 pi, ut minus pi minus ut minus 2 pi. And for third bracket, this third bracket comes from third condition, as there is only one term, one limit, that is 2 pi, so take u of t minus 2 pi, u of t minus 2 pi. So in this way, so simplify this, ut minus 0 is ut, and multiply the sin t to this bracket, sin 2t to this bracket, sin 3t to this bracket, we get this answer. So this is your final ft, and you can see that this function given in example, this function and this function, converted function, is they are different, because in this we can see that there is a bracketed term, ut minus pi, ut minus 2 pi, ut, that is these brackets we want in the unit step function, and these brackets are not in this example. So hence this given example is not unit step function. We have to convert this given example, regular example or regular function, into unit step function as like this by using this formula. So remember this formula. Next example is these some are examples for converting into unit step function. So function ft is equal to e raised to minus t and 0 in conditions are given. So this is your unit step function, converted unit step function. First function into bracket u raised to minus t into bracket plus 0 into bracket. So in bracket, first bracket comes from this first condition, 0 and 3 there. So ut minus 0, ut minus 3, ut minus 0, ut minus 3, and plus 0 into bracket, only 3 is there, so ut minus 3 we have to take. So simplify this and multiply e raised to minus 2 this each bracket. So 0 into bracket is 0. So e raised to minus t into ut minus 0 is ut minus ut minus 3, and multiply this e raised to minus t to this bracket. We get the Heaviside unit step function. Then ft equal to sin t greater than pi, and cos t when t is in between 0 to pi. So ft equal to first function you can write as this is your first condition 0 to pi, and then for 0 to pi function is cos t, and from greater than pi t greater than pi the function is sin t. So you can take this cos t function at the first, and or you can write as it is, or you can take as it is the sin t function as first position and cos t as second function. So ft equal to first function or cos t into bracket plus sin t into bracket. So cos t into, from this condition, ut minus 0 minus ut minus pi, and plus sin t into, there is only pi only, so ut minus pi, only one term is there. Simplify ut minus 0 and multiply this cos t to this and sin t into ut minus pi, we get the Heaviside unit step function. Next is ft equal to 0 sin t, and conditions are there. So we get, so you can take this as a assignment. So let us see how to convert into unit step function. So 2 plus 0 plus sin t, and 2 into bracket plus 0 into bracket plus sin t into bracket, and in this bracket, first bracket 0 and pi there, so ut minus 0 ut minus pi. In second bracket ut minus pi ut minus 2 pi. In third bracket only one term is there, so ut minus 2 pi. So this is your Heaviside unit step function. Simplify this, we get the final answer. As Laplace of ut is 1 by s, because this is your first formula, ut minus a 1 by s e raised to minus as. So Laplace of ft is, put a equal to 0 here, because to have Laplace of ft or Laplace of ut, to have Laplace of ut there, we have to take a equal to 0. So put this a equal to 0 in this answer, or in this formula, we get 1 by s e raised to minus 0, that is e raised to minus 0 1, we get 1 by s only. So Laplace of ut is 1 by s from the first formula. Then Laplace of ut minus pi. So for this, for Laplace of ut minus pi, which formula we have to use? First, second and third. First formula is for only u function. Second formula is for f into u function. In that, both the brackets are same. T minus a function, bracketed function, t minus a bracketed function. And third formula is only for product of two functions. One function is your regular function, ft function, and second function is our unit step function, that is t minus a bracketed function. So here there is only one term, ut minus pi, so use first formula. So to apply this first formula, compare this left side of this formula with the given example, we get ut minus pi and ut minus a, we get a equal to pi. And put this, to apply property or to apply the formula, first two steps are important. We have to remember these two steps, that is, first comparison by the left side, and whatever we get the values, put these values in the RHS of formula, and that answer is your given example answer. So by comparison of left side, we get a equal to pi, put this a equal to pi here, we get 1 by s e raised to minus pi s, and that is your answer of given example. So here a is equal to pi, put here in this first formula 1 by s e raised to minus pi s. So this is your answer of Laplace of ut minus pi. Then find the Laplace transform of sin t into ut minus 2 pi. So this function is similar to which formula? First formula is only for single term, u term. So first formula we can't use here. Second formula again not applicable, because here there is a product of two functions. One function is unit step function of t minus 2 pi bracketed term, and another function is t function. So here f function is again compulsory of t minus a bracketed term, which is the bracket similar to this unit step function. So here this is your t function, t type function, function in the form of t variable, and this is your bracketed function t minus 2 pi. So this second formula we can't apply here because both the functions should be of bracketed term. So here only one function is bracketed term. So we have to use third formula, because in third formula one function is of t variable, another function is of bracketed function. So here one function is sin t, that is t variable in the form of t variable, and second function is of bracketed function. So third formula we can apply. First formula can't because there is only one term, and here there is a product of two term. So first formula fails. Second formula we can't apply because there is a product of two functions. Here, as there is a product of two function, but only one function is of bracketed term. Only one function is of bracketed term, and in the second formula both the functions should be of bracketed in the form of bracket, that is t minus a. Same bracket should be there for f function and u function, t minus a bracket, t minus a bracket. So t minus 2 pi, this bracket is only for one function, so we have to use third formula. So compare this left side, ft ut minus a sin t ut minus 2 pi, we get ft equal to sin t, and from ut minus a ut minus 2 pi we get a equal to 2 pi. So by comparison of left side we get a equal to 2 pi and ft equal to sin t. Put these values in the RHS of this formula, we get e raised to minus a value is 2 pi, e raised to minus 2 pi is Laplace of f of t plus a value is 2 pi, f of t plus 2 pi. So after putting these values in this RHS, that is your answer of this given example. So by comparison we get these values, put these two values in the formula, we get this answer, and this answer is of our given example, Laplace of sin t into ut minus 2 pi. So simplify this, e raised to minus 2 pi is as it is, Laplace of f of t plus 2 pi. So we have to find the Laplace transform of f of t plus 2 pi. So before that, find this function first, f of t plus 2 pi. So here ft is sin t, ft is sin t. Then what is the value of f of t plus 2 pi? That is, here for t function is sin t, and for t plus 2 pi we have to replace t by t plus 2 pi. So replace t equal to t plus 2 pi, again on the RHS replace t by t plus 2 pi. We get the f of t plus 2 pi value. So here as ft equal to sin t, then from this we have to find first f of t plus 2 pi. So replace this t by t plus 2 pi, replace t by t plus 2 pi, we get f of t plus 2 pi function as sin t plus 2 pi. So find Laplace of sin t plus 2 pi. So here for finding Laplace of sin term, the standard formula for Laplace transform is Laplace of sin at. Sin at Laplace is a upon s square plus a square. But instead of sin at, that is number multiplied to t variable, this at angle, this type of angle is not given here. The angle is 80 means only single variable for applying this formula, single variable into number, that is sin 2t, sin 3t, sin 4t, sin 1 by 2t. For that we can directly apply this formula, but this formula we can't apply directly for this sin t plus 2 pi because number into t, this type of angle is not there. Additional angle is there, that is t plus 2 pi. So for that we have to first, before taking Laplace transform, we have to first simplify this sin t plus 2 pi. So how to simplify? So you can remember as a formula, a direct formula, that sine 2 pi plus theta is sine theta. So sine 2 pi plus t is sine t. So this is your standard formula, and this is the general formula. In Fourier series in M2, Engineering Mathematics 2, you come across this formula, sin n pi plus theta minus 1 raised to n sin theta. So here sin apply for sin 2 pi plus theta. Theta value is t, and for n pi value, n value is 2. So put n equal to minus 1 raised to 2 sin theta. Theta value is t. So sin, we get sin t here. So minus 1 square is 1 sin t. So we get sin 2 pi plus t is sin t. Or you can use sin a plus b formula. So by 3 option you can simplify this. Directly remember this formula, sin 2 pi plus theta is sin theta. Or remember this formula, sin n pi plus theta is minus 1 raised to n sin theta, and by comparing put n equal to 2 and theta equal to t, we get the answer. Or this is your general, many times you have used in 12th standard, this formula, sin a plus b is sin a cos b cos a sin b. So sin cos plus cos sin, ab. So a value is t, b value is 2 pi. So put these values, sin t cos 2 pi plus cos t sin 2 pi. So in this, sin 2 pi value is 0 by the circle formula. Sin 2 pi value is 0, so 0 into cos t is 0, and cos 2 pi value is 1, because cos 0 is sin a plus b formula is sin cos plus cos sin. Cos 2 pi value is again 1, because cos 0 angle, for 0 angle cos 0 value is 1, and 2 pi angle is again come to this 0 angle, 0 pi by 2 pi, 3 pi by 2, and again 2 pi. So for 2 pi angle, again the value of cos is 1. So this 1 into sin t is sin t. So this is the simpler formula. So you can remember this. So we get Laplace of sin t. So sin t Laplace is by using sin at. Now you can use this direct formula, sin at, number into variable. Number is 1. So a value is 1. So put here 1 upon a square plus 1 square. That is 1. 1 upon a square plus 1. So this is your answer. So in this Laplace of sin t ut minus 2 pi, we used here third formula, t variable function and t minus a bracketed function. So this function matched with third formula. Compare this left side with this given example. Find the value of a and ft. Put these two values in this right side of this formula. Whatever we get, that is your answer of this given example. For simplification of this Laplace of ft plus 2 pi, the ft is sin t, then f of t plus 2 pi is sin t plus 2 pi. Put here, so Laplace of sin t plus 2 pi, we can't directly use this Laplace of sin at formula. So before that, simplify this sin t plus 2 pi by using sin a plus b formula. By simplifying, we get sin t and Laplace of sin t. Now we can use sin at formula. Sin at Laplace is a upon a square plus a square. Sin t Laplace is a value is here 1. So 1 upon a square plus